Okay, we're talking about binomial probability. This is going to be our last section of the year. In the previous section, we talked about how to compute binomial probabilities, that is, in situations where there are two possible outcomes for the individual trials. What we're going to do in this video is extend the binomial probability theorem that we learned about in the last section into a new set of cases where we want to deal with not just what's the probability of an individual result, but of a particular number of positive results, but an at least or at most situation. So whereas in the previous video we might have said, if I roll the die 6 times, what's the probability that I'll get exactly 5 3s? In this video we want to look at what's the probability that I get at least 5 3s. So that's the only difference. It just means we're going to do basically just do some addition, kind of do repeated iterations of the binomial theorem and then add the results together. Let's look at example 1 here. It says a coin is tossed 10 times. What is the probability of at least landing on heads? Sorry, it's a bit redundant here. It says at least twice, so let's get rid of that one. What is the probability of landing on heads at least 8 times? Okay, so if I flip a coin 10 times, we'll define our variable x as the number of heads. What we're interested in is the probability of x being at least 8. That is greater than 8 or equal to 8. Well, something is greater than or equal to 8, that means we could get exactly 8 heads, right? So we would end up with x equals 8. That's one possibility. But we also could have 9 heads. That would be another possibility. Or we could have 10 heads. That would also satisfy this at least phrase. There are 10 flips, so that's the cap. We wouldn't have any higher than that. But the probability of having at least 8 heads is the probability that any of these 3 happen, and none of the 3 could happen at the same time. So we can just add those 3 probabilities together, and that would give us the probability of getting at least 8 heads. Well, each of these is just an individual case of what we learned about in the last section, okay? So we want to think about the number of trials that we're going to do, the probability of success, probability of failure. So we're going to do 10 trials, right? We're flipping the coin 10 times. The probability of success, that is getting heads, the probability of getting heads, of course, is 1/2. And then the probability of failing, probability of not getting heads, is also 1/2. So, but the number of successes are, as we defined it in the formula, well, we could get 8 successes or 9 or 10. So we need to do all 3 of those scenarios, find all 3 of those probabilities, and add them together. So the probability of getting exactly 8 heads, well, we learned in the previous section we're going to do a combination here with the number of trials on the left and the number of successes on the right. So we want 10c8 times the probability of success raised to the number of successes power times the probability of failure, which is also 1/2, times the number of failures, or raised to the power, that is the number of failures. So we have 10c8 times 1/2 to the 8th power times 1/2 to the 2nd power. That's the probability of getting exactly 8 heads. And it's going to be really redundant now. The probability of getting 9 heads would be 10c9 times 1/2 to the 9th power times 1/2 to the 1st power. We'd only have 1 tails. And then our last possibility, getting all 10 heads, would be 10c10 times 1/2 to the 10th power times 1/2. Now we would want 0 failures, so we'd have 1/2 to the 0 power. And now all we need to do really is type that all into the calculator and find our result. So we could type that all in the calculator in one shot, and we'll see. I've already entered it into the calculator for us here. Okay, so we've got 10c8 times 0.5 to the 8th power times 0.5 to the 2nd power, etc. We're going to add the 3 probabilities together. If you want to be extra clear, put each probability into its own set of parentheses. That shouldn't be necessary, but it never hurts to be extra clear. Okay, but that helps us at least to visualize, see that that's the probability of 8 heads right there in that first set of parentheses. This is the probability of 9 heads, and then lastly we have the probability of 10 heads is our last expression here. We have 1 extra pair of parentheses than we need. Okay, so now we can just hit enter, and there's our probability. So this is our probability then that the total number of heads is at least 8. We could have 8 or 9 or 10. Any of those three possibilities, add them all together, we get 0.0547 if we round. So there we go. Our probability of at least 8 heads is 0.0547. Okay, and we'll have one more video where we do one more example, but it'll be real similar, and then we'll be done.